All right, this is graphing our sine and cosine, putting it all together. So we have our y equals k, a sine b, x minus h. And the y and the x are the only two variables here. The other are our constants that we're going to be plugging in. So you have 4 letters. Each one affects it in 4 different ways. A is the amplitude. B affects the period. H is our horizontal shift, so it affects the x, and it's always opposite. That's why it's got a minus on there. This one is always opposite. And then k is our vertical shift. And then our period would be h, and then h plus our period. That's the interval for one period. So let's break this thing apart. Before we start any of them, they have to be in that form. So this would be 1 plus 3 sine, and then we have to factor that 4 out to get that nice, clean inside. And all you're doing is dividing it out. So whatever number you put here, you just divide that number into the 2 pi. So like that. And that would give us pi over 2. And then you always double check just by distributing. This would be 4 times x, check. And then 4 pi over 2 reduced would be 2 pi. So we take out a 4, you divide a 4, everything's perfect. Now let's pull each of those letters out. So let's start with our amplitude. Our amplitude here is 3. Right there is 3. And then we'll move on to our period, and that is affected by our 4. So it's always 2 pi divided by whatever that b is, and so this is pi over 2. But then we also need to know where our marks are, so we take a fourth of that. So it's pi over 8. So we know our marks will be pi over 8 in spacing. Now we have a vertical shift here, and that's the 1. So let's do that one in yellow. That one's 1. And so we're going to have an equation of y equals 1 for our vertical shift. So we're going to go up 1 right off the bat and put a dotted line like that. And so that is actually what we're going to oscillate across. And then we do also have a horizontal phase shift, and that's our h. And we'll do that one in pink. So pi over 2. And if you remember, it's always opposite. So this would now be negative pi over 2. So we are going to shift this pi over 2 units to the left. Now we already know our spacing is pi over 8, so we should probably put that on there. So this would be pi over 8. This would be 2 pi over 8, so pi over 4. That's 2 pi over 8. And then 3 pi over 8. And then 4 pi over 8, which is our pi over 2, but we want to go the other way. So negative pi over 8, negative pi over 4, negative 3 pi over 8, and then negative pi over 2. And we need that because that horizontal phase shift is basically where we're starting our graph now. So I like to put a little dotted line right there to start it. And so you can then see our 4 marks from there. So it's 1, 2, 3, 4. That will be our basic shift. So we're going to go from negative pi over 2, right? And then from negative pi over 2 plus our period, which gives us negative pi over 2, comma 0, which matches perfectly with what we want. We want negative pi over 2 to 0. So again, you take the period, cut it into fourths to find out what the spacing is. We're going to start it at whatever the shift is, so that number is exactly where we start. 4 marks from there will be our period, and now we just have to place our amplitude. So from y equals 1, we're going to go up 3, 1, 2, 3, and that's our height, and I like to put another dotted line, and then down 3, so 1, 2, 3. So we're going to go from negative 2 all the way up to 1, 2, 3, 4. So if you look at these, they tell you what the amplitude, what the range is. So we're going to go from 1, we're going to go up 3, so up to 4. And then from 1, you're going to subtract 3, so negative 2. So our range would be from negative 2 to 4. So we start with sine. Sine starts at 0, so it starts right on that y equals 1. And then we go to the top, back to the middle, back down to the bottom. Let's put this in red so we can see it. And then right back here. So it goes up to 4, back down to 0, and then back down to negative 2, and then back up to 0 right there. It's not 0, it's that guy right there. So there it is. There are our points from there to there to there. And then it would continue over and over and over again. And now what we want to do is verify it in the calculator. So if everything was correct, everything should check perfectly. So if we enter this thing perfectly, 1 plus 3 sine, and then it's 4x plus 2 pi, close the parenthesis. Make sure the mode is in radians, and then we set our window. So we know that we're going to go from negative pi over 2 to 0, and so from that point, negative pi divided by 2 to an x max of 0, right? And then we do our y min. Our y min goes from negative 2 to 4. Entering all this in, if I hit graph now, it should be our perfect graph. So there's our y equals 1. And you see it went all the way up, all the way down, and then right back exactly where we needed it. So our graph is perfect, which means we translated this perfectly. Now, there's another way to find your intervals as well to test that. And all you have to do is take that inside part, the 4x plus 2 pi, and say, well, sine normally goes from 0 to 2 pi. And then you solve it for x. So x equals negative pi over 2. And x equals 0. So we know we're going to go from negative pi over 2 to 0. So if you input this exact function into your graphing calculator on this interval and then hit zoom 0, it would give you the exact same graph as well. So watch, if I hit zoom 0 with that same domain that we already inputted, it gives me that exact graph. It will go to your highest point and to your lowest. And you can even see here that it's a high of 4 and a low of negative 2. So it's a quick way to verify everything is correct. All right, let's try it one more time with cosine, and it's the same exact idea. So we're going to take this and rewrite it first. So this would be 3 plus 2 cosine, and this time we're factoring out a half. And so if I factor out a half, I would be dividing by a half, which really means I'm multiplying by 2. So that would be plus 2 pi. And we check it. So that would be 1/2 x, and then 1/2 of 2 pi is pi. So everything checks perfectly. And so again, this is our starting point. We know we are going to start at the opposite of that. So we are starting at negative 2 pi on our graph. And this is going to oscillate around 3. So y equals 3. Our amplitude is 2. So 2. So we're going to go from 3, we'll go up 2 and down 2. So from positive 1 to 5. And then our period is that nice clean guy. He is the most important one right here, that half. So 2 pi over a half, again, is going to occur half as fast, so it's going to be twice as long. So this is really 2 pi times 2 again, which is 4 pi. And if I break that up, you get pi. So that is our spacing. So you want to go 1, 2, 3, 4, and put pi in there. Pi, 2 pi, 3 pi. That looks like a Roman numeral 2. Pi, 4 pi. But what we really need again is negative 2 pi, because that is where we're starting. So we are going to start here with our cosine. And again, it starts on that number from 3. So we go to y equals 3. And another way to do this is you can actually say that this is y equals 3. This is an alternate method. So you can either draw a line, or you can say that that line is y equals 3. And so from that 3, we will count up 2. And that makes this a 5. And then down 2, which makes it a 1. So now it's 1, 2, 3, 4, 5. Everything matches. And we know our marks are pi. So we are going to be starting at negative 2 pi. And then we'll go from negative 2 pi with a period of 4 pi. So our period will go from negative 2 pi to 2 pi. You can also verify this like we did before using that internal area. So 1/2 x plus pi goes from 0, and that 1/2 x plus pi goes to 2 pi. And then solving this, times 2 times 2, so x equals negative 2 pi. That's exactly what we wanted. And 1/2 x equals pi times 2 times 2, x equals 2 pi. So you can see that we are still going from negative 2 pi to 2 pi. Now, cosine, we know, starts at whatever number that is. So if that was a negative 2, I'd be starting at 2 units down. If that's a positive 2, I start at 2 units up. So we start here, and then again we go to 0, and then down to the lowest, and then back up to 0, and then back here. So you can see there is our 4 marks. Perfect. There's 1, 2, 3, 4, and then it would repeat. And so that is our graph. Now, we just have to check it in the graphing calculator. So, we bring it up. We clear that guy out from last time, and we enter it. And always enter in the non-simplified form, because if you make a mistake in your factoring, it will show you here. So now I have entered it. And then again, our window, either from doing this or this, we know we go from negative 2 pi to 2 pi. And now you can do what we know it is from negative 1 to 5 here, or just hit zoom, and 0 means fit. You can see if you scroll down, it will say fit. So what it'll do is fit it for us on that interval. And so there it is. There's our height, and you can see it's at, that's 1, 2, 3, 4, 5, and it fits perfectly in there. You can even put in the steps. So you can say your scalar here is pi units. That's whatever that one is. So second pi. And then when you graph it, you can see that there's 4 marks that we needed perfectly. You can even pull up this point, which is 0, negative 1. So if I hit trace and 0 and hit enter, you see it says positive 1. Sorry, see, I'm even wrong there. It is a positive 1 on my graph. And so you can test each of these very, very clearly. But those 4 points, that's how you use them. Thank you.